Hi, decision tree is one of the simplest methods for decision making. In this video, we will discuss decision tree and random forest algorithms. Suppose that we want to play football today. Let's use a decision tree to make a decision. We can start by asking a question. Do we have the time? If we don't, well then that is an easy decision, no football. But let's say we do. Second decision point, is it sunny today? If it is not sunny, then we don't care about any other factor. We will not play football. If it is sunny, let's go down to the next level. Do we have proper shoes? If we do not, then we are not going to bother playing. If we do, then we will. The decision tree here is an example of a classification problem where the class labels are football yes and football no. While decision trees are helpful and easy to use, they can be prone to problems like bias and overfitting. Random forest is a type of machine learning algorithm that uses an ensemble of decision trees to make predictions. And why do we call it random forest? Well, the reason is because it is actually built by taking a random sample of the data and then building an ongoing series of decision trees on those subsets. The more decision trees that we use with different criteria, the better our random forest will perform because it is essentially increasing our prediction accuracy. A decision is made by majority voting. That implies that if more trees produce yes, then the result is yes. One of the primary benefits of random forest is that it can help reduce overfitting, which occurs when your model starts to memorize the data rather than trying generalize the data for making predictions on future data. It can also help reduce bias. Bias can occur when there is a certain degree of error introduced into the model. Bias occurs when you are not evenly splitting your instance space during training. So instead of seeing all of the data points, you might see only half because of how you set your model up. Now, to set up a random forest, we will set some parameters. We have parameters for the node size, we have parameters for the number of trees, and we also have parameters for the number of features. And it can be challenging at first, because we will want to use a lot of trees to get the best predictive accuracy. But we don't want so many trees that it will take you a long time to train the model and use a lot of memory space. Random forest is popular among data science professionals, and for a good reason. It can be extremely helpful in all sorts of classification problems. It is used in finance because it can predict the likelihood of a default. In medical diagnosis, it can be used to predict the prognosis or the survival rate depending on treatment options. And in economics, it can be used to estimate a policy's effectiveness. Thank you.